Today we are going to talk about parallelograms. By the end of class, you will be able to label the base and height of a parallelogram. But let's start backed up a little. Let's go ahead and talk about what is a parallelogram. Well, here we've got 6 figures, and we are told that A, B, and C are all parallelograms, whereas D, E, and F are not parallelograms. So I want you to take a minute and look at these 6 figures, these 6 shapes. Why are A, B, and C considered parallelograms? What makes them parallelograms? What do these 3 have in common that make them parallelograms? And then also looking at D, E, and F. What are these missing? How are these 3 different than A, B, and C, making them not parallelograms? In a moment, you're going to pause the video, and I want you to ask yourself these questions. What makes these parallelograms? What makes these not parallelograms? So go ahead and pause the video and answer some questions about your thoughts. Wow, we've got some great thoughts, some great observations about A, B, and C's similarities, and also some interesting points about D, E, and F. Now I would like to go through 4 things that make a parallelogram. The first is all parallelograms are quadrilaterals. These are 4-sided figures. As you can see, A has 4 sides, B has 4 sides, and C has 4 sides. D and F also have 4 sides, but there must be something else that makes them not a parallelogram. All parallelograms are quadrilaterals. All parallelograms also have opposite sides that are parallel, that will never meet. Okay, so for example, A, this side is opposite of this side, and they run parallel to each other, so they will never meet. Same with the other set of opposite sides on that parallelogram. Here, these 2 are opposite, but they will meet. Sometimes it's easier to see that with a marker or pencil. These also. These opposite sides are parallel, but as we stated, there's not 4 sides. And then this has 1 set of parallel sides, but not 2 sets of parallel sides. Observation number 3 is that opposite sides are congruent. They are the same length. So not only are they parallel to each other, but they have the same measurement length. And then lastly, opposite angles are also congruent. So again, as we see up here, opposite sides have the same measurements in all of our parallelograms, whereas that is not the case. This one has 4 that are the same. That is not the same in our other 3 figures. So quadrilaterals, parallelograms are all quadrilaterals. They have all opposite sides parallel, all opposite sides congruent, and all opposite angles are congruent. Let's take a look at the next piece here, and that would be the bases and heights of a parallelogram. So here we have some examples of correctly placed bases and heights. And here we have some non-examples. These are not correctly placed bases and heights. As you can see, a base is always labeled, and then that dashed line is your height. So whenever you have that dashed line, that is where we are stating the height is. Now, these are correct. They are appropriate examples. These are not appropriate examples. These are not correctly labeled. So my question for you is, now you're going to pause the video. And again, I just want you to make some observations. What do you notice that these examples have in common, making them correct? And then again over here, what makes these non-examples similar to each other, but different than these examples? So pause the video and go ahead and answer some questions. Great. So we had a lot of cool thoughts. We saw a lot of different things between our examples and our non-examples. Let's go ahead and go through a couple of true-false statements to determine what we need to know about bases and heights of parallelograms. Our first true-false statement says that only a horizontal side of a parallelogram can be a base. So a horizontal side is that side, right? Side to side. So for example, here is horizontal. And yes, in this case, the base is horizontal, but here our base is vertical. So that is not true. That is false. We can have both horizontal and vertical sides as our base. Okay, what about number 2? Any side of a parallelogram can be a base. That is true. We will circle that. Yep, you can make any side the base. See how we have a wide variety of bases here. What matters is then how you create your height from that base. See here, we do have bases on all sides, but the height differs from that base. For example, here they say the height's opposite of the base. That's not appropriate. So the base can be any side, but then you need to appropriately place your height. Speaking of heights, a height can be drawn at any angle to the side chosen as a base. Now, up here in our examples and non-examples, you'll see that these all have those little boxes. Does anybody remember what those little boxes mean? What does that signify? Good. So these little boxes mean that we have a 90-degree angle. Notice that in all of our examples, our height meets our base at 90 degrees. We have those boxes for every single one. Here, that's not 90 degrees. That's not 90 degrees. That's not 90 degrees. That is... but we'll keep going. It's not still a non-example. So our base has to meet our height at 90 degrees. So not any angle. That is false. It must be a 90 degree. Ooh, look at that. Our next one says a base and its corresponding height must be perpendicular. We know that perpendicular means a 90-degree angle. That is true. Yes, they must meet at a 90-degree angle. All right, letter E, a height can only be drawn inside a parallelogram. Well, let's take a look up here in our examples. These 3 are drawn inside. This one's outside, and that still works. Now, I want to point something out to you. This base was extended to appropriately make our height. However, when we're measuring, our base is still only the part of the figure. This little bit is ignored. It's just used to help us make that 90-degree height. So if we were measuring, we would only use this as our base. This is just a guide to help us appropriately make that height. All right, so a height does not have to be inside. That is false. 2 more to go here. A height can be drawn outside of a parallelogram as long as it is drawn at a 90-degree angle to the base. That is true, as we just saw. And then lastly, a base cannot be extended to meet a height. This is false. Like we just said, we can extend it. We just need to remember that when we do extend it, when we're measuring, we only measure the actual side of the figure, and we ignore that little piece. All right, we've got 2 more things to take a look at here. Down here, we've got 2 different parallelograms, and we have our base labeled as B in each of them. And your task is to now go ahead and place your height somewhere. Now, you can place your height in several different places. Now, I know it needs to connect to this base somewhere. So the first one I usually would like to go to is right here. That meets at a 90-degree and goes straight to the other side, the opposite side. Now, if I wanted, I could extend my base here and then make my height outside. Typically, if I can make a height inside, I do that. But you are welcome to do the outside one as well, if that makes more sense. And that goes, then you can kind of see, it looks like a rectangle. So those are 2 options. One more option would be from right here. Again, coming from that base at a right angle. Go ahead and pause your video and pick a height for this parallelogram. So one option would be here. We could do outside if we extend there. We've got another one here. You could do out here, or excuse me, over here. Lots of options.